Okay, here is warm-up 5.7. We've got a series of overlapping triangles on these first three problems, and the question's asking what do those overlapping triangles share. So in this first problem, they share this side at the top. That's the top of both triangles. So these share side BC. So anytime you have overlapping triangles like this, they're either going to share a side or possibly an angle. On this next one, the overlapping triangles, the bottom of both of those triangles is segment EH. The third set, it doesn't share a side. This segment right here is part of this triangle, but it's only part of the side of the other overlapping triangle, but they do share this angle at the top, right? This angle L is the angle that's at the top of both angles, so these share angle L. And so when you see overlapping triangles like this in proofs, you can use the reflexive property to say BC is congruent to itself, or EH, or angle L. And that can get you one of the pieces you need for SSS or SAS or one of those. Okay? All right, moving on. This next problem, I've got two triangles here. And just looking at these two triangles, we've got two sets of angles that are congruent within the two triangles, and one set of sides. And these sides are not, they're not included sides. So the included side between these two angles would be where the 13 is. So this is a non-included side. Same thing here, this side's not included between those two angles. So these triangles are going to be congruent by AAS. And it doesn't ask me to say that, but now that I know that these are congruent triangles, then I know that all of the sides and angles will have a corresponding part in the other triangle. Okay? All right, so let's start looking at this then. We already know that those two sides are congruent. These two sides are going to be congruent as well. They'll be matching parts, so that means y is going to be 6. And let's see. This last remaining set of sides will be congruent, and I don't need the 13 there, but that is going to be 13. Okay. And this matches up with this, and 34 matches up with that. Okay, so we still need to solve for x and z. And the way we can do this is, well, there's two ways. Now, if you look at this triangle here, we have two of the three angles. You could also say vertical angles or the corresponding parts of these triangles. Those are both 81. So now I can use either of the triangles and use all three angles are going to have a sum of 180 degrees. Okay, so then I'll combine 34 and 81. It's going to be 115. Okay, and then I'll subtract 115 from both sides. And x is going to equal 65 degrees. Or actually, it's just 65 because it already has the degree symbol there. Okay, so that's what x equals. All right. And then for z, there's two different ways that we can find z. One way we could do this, we've got these are going to form a linear pair. So these two together will be supplementary, and that's the way I'm going to do this. You could also use the remote interior angles theorem. Z is going to be congruent to the sum of these two angles, these two remote interiors. But I'll just say z plus 34 is going to equal 180 degrees. And then, let's see. So that's going to be 146. Okay, and again, I don't need the degree symbol because it's in the diagram there. Okay. All right, last but not least, we're going to do a two-column proof here. Okay, so my first statement is going to be just the given info. So I'm not even really looking at the proof yet, but I'm just copying the info that is given. Okay, and my reason for that is going to be given. Okay, so I should really write that these are my statements and reasons or justifications on the right. Okay. And I like to label everything so I can tell that that statement goes with that reason and so forth. Okay, so that's my given info. What I like to do is make sure the given info is in the diagram, and if it isn't, add it in. So this says PS and RT are parallel, that's already in there, and then PQ and TQ are congruent, that's in there too. Okay. So I'm trying to prove that these triangles are congruent. So right now I only have one set of sides that I can say are congruent. So let's try to find something else. Well, I call this the bow tie situation. It kind of looks like a bow tie, or if it was turned on its side, an hourglass. And that means we've got these intersecting lines in the middle. And when you have that, the angles opposite those are going to be congruent. Those are vertical angles. I don't want to call those just angle Q. I'd have to use 3 letters. So I'm going to call this PQS on the left. So angle PQS is congruent to angle RQT. Okay, and that's the vertical angles theorem that allows me to say that. Vertical angles are always congruent. Okay, so I've got a set of sides, set of angles, still not enough. Now I'm going to use these parallel lines. Okay, and you could have used the parallel lines step right after the given if you wanted to. So if those are my parallel lines, I'm thinking about those as tracks, and then I'm going to pick a transversal, and I've got 2 transversals to choose from. It doesn't really matter which one you use. I'm going to use this one. Okay. If I look at those 3 green angles that I formed, this angle here and this angle here are going to be congruent because they are alternate interior angles. They're on the inside of the tracks, they're on alternate sides of the transversal, so these are going to be congruent to each other by the alternate interior angles theorem. So let's call this, I can just call that angle P. There's really only one angle P and one angle T in the diagram. Okay, and you could do the same kind of thing with these 2 angles. You could use this as your transversal, and then those would be alternate interiors and would be congruent. But I actually don't need to do that. I have enough already because I've got 2 angles and an included side here. This is the side between those 2 angles, and same thing here. So now I can finish the proof by ASA. So I can say the 2 triangles are congruent by the angle side angle triangle congruency theorem. I'm going to write like that for short. Okay? And I want my last statement always to be what I'm trying to prove, so I'm just going to copy this. I'm going to name the triangles in the same way they were named in the given info, or not in the given, in what we're trying to prove in the original problem. Okay? That's the end of the warm-up, and I'll see you next time.